So I know these notes look a little bit different. I stole them from a different resource that I had. So it says an equation uses an equal sign to show that both sides are equal. An inequality shows that both sides are not equal. Okay. Let me just see it real quick. Sorry, I just felt like it was kind of fuzzy. Oops. Okay. Just won't let me zoom in anymore. Silly. So I'm just going to go through the 4 symbols. Greater than opens to the left. Greater than or equal to has a equal or that line underneath it. Less than opens to the right. Less than or equal to opens to the right but has a line underneath it. And then not equal is an equal sign with a slash through it. Okay. So one thing that I always talk about is that the bigger number is always going to be eaten by, let's pretend he's a Pac-Man. Okay. So who's bigger, 4 or 9? 9 is bigger. When we're dealing with decimals, remember that we can add another digit after the digits to compare. So who's bigger, 50 or 45? The 50.5 is larger. And then with negatives, we have to deal with the fact that the bigger the negative, the smaller it actually is. So the colder it is, the smaller it is. So we're going to talk about how we read these statements. So it doesn't matter if the number is on the left or the right. This statement would say x is less than or equal to, or 6 is less than or equal to x. And we could also say that x is greater than or equal to 6. Okay. You always, one thing that I do is when I'm reading it, I read it left to right. And this is the less than side. So whatever comes first, if it's the other way, you would say greater than, and if whatever side you encounter first. So for example, this one, y, or you could say a variable, is less than 0.5, or you could say 0.5 is greater than y, okay? Even though I switched the order, it doesn't matter. Okay. Austin keeps getting kicked out. Sorry, I just was reading my comment here. He's not, doesn't look like he's trying to get back on though. Oh, Austin, you're right there. Mason, is that you?
Yeah. He says he can hear you talk for about 15 seconds and then he gets kicked again.
Okay. You should see if he can go to a place in his house that maybe gets better Wi-Fi. Like if he can move towards the router, that might be one reason, like if he's just too far away from the router. Okay, so just ignore it. Use the blank as a starting point when reading inequalities. I just say read left to right. Okay, just like you're reading a book or a sentence. So the first type of problem, we don't have to go through all of these, but it says determine whether each value makes a true statement or not. So first off, they give you an inequality, then they tell you what K is. So for example, if I put 11 in for k, this would be 11 plus 8 greater than or equal to 19. Well, what's 11 plus 8? That's 19. Is 19 greater than or equal to 19? And yes, it is. I know that it's not greater than, but the big phrase here is or. So 19 is greater than or equal to, and it is equal to. So that means that it is true.
Can you like make it bigger? Like can't see.
Okay, it wouldn't let me for some reason. Let me pause. Okay, so anyways, you can just go through, and we don't have to do all of these. I think you guys can get the image pretty quick on how this is gonna work. So is 12 greater than 3? Yes, 12 is greater than 3. So 3 made the statement true, okay? Number 3, 3 is greater than 3. Is that true? No. 3 is not greater than 3, it's just equal to. So 3 does not make it true. If you put 13 in, 13 minus 12, oops, sorry, there's no line underneath that one. 13 minus 12 is 1. Is 1 greater than 30? No. Put 22 in. 22 minus 8. And so it would be 14. Is 16 less than 14? No. So you guys can kind of see how this goes. I'll do a couple more because these give you kind of two-step equations. So 5 is going to go in for x. So 6 times 5 plus 5 is less than 18. Well, you can't determine if it's true or not until after you do it. 6 times 5 is 30. 30 plus 5 is less than 18. Is 35 less than 18? No. Do you guys need me to do more? Think you got it?
Yeah.
Okay, maybe I'll just do one more just for fun. I'll do number 8. Okay, so I'm going to put 6 in. So 5 times 6 minus 3 is greater than or equal to 25. 5 times 6 is 30. 30 minus 3 is 27. 27 is greater than or equal to 25. Yes, it is. Okay, so just remember the open end of the expression is always going to be towards the larger number. Okay, so now there's a couple different things when we come to graphing, sorry. So inequalities can also be graphed on the number line. Okay, so we've got two different kinds of circles. One is a shaded circle, and that means included. So greater than or equal to or less than or equal to are the two inequalities that will produce a shaded circle. Greater than or less than without the line underneath it will produce an open circle is how I call them. So if I were to look at this inequality, I would determine if I use an open or a closed circle and where that circle is going to go. So this is a closed circle because it says x is less than or equal to 5. So I'd put a closed circle on 5. And x is all the numbers that are less than 5. So what numbers do I shade? I shade to my left. And when you guys graph, you have to make sure that it's big enough for me and dark enough so that I can tell where you graph. Or use a highlighter. So what would make this inequality true are any numbers that are greater or less than or equal to 5. And so what they're saying with this shaded in circle, that 5 would make this true because 5 is equal to. Okay. So we are going to graph the next inequalities. So number 10 is an open circle on 11. K is greater than 11. So what numbers are greater than 11? Well, 12, 13, 14, so it goes that way. Number 11, a closed circle on 12. Now this one, they switched which side of the inequality the variable's on, but I know that f is less than. So I have to shade the numbers that would make this true, which would be 11, 10, 9, this way. Sorry, that's really hard to read. Less than. F is less than 12. D, or number 12, D is less than 6. So an open circle on 6, less than 6 are all the numbers to the left. Number 13, I would have an open circle on 25, because it does not include 25. It says C is less than 25, so the numbers that are less than are shaded. Again, they switched them around. B, though, is greater than. So a closed circle on 0. The variable is bigger than 0, so I have to shade all of the numbers that are larger. And then the last one, even when they give you a decimal, and we don't have decimals on here, we know that 4.5 would be halfway. Okay, and it's a closed circle. X is greater than or equal to 4.5, so I'm going to shade the greater than direction. Okay, any questions on 10 through 15 on graphing them? Okay, so the last two examples, we have kind of a word problem. So it says that it wants us to write and graph the inequality. So it says the McDonald family spends no more than $150 for groceries each week. So again, one thing that I will do is I just start with my X and then my number. Can the amount that they spend, and I'll write this out in words maybe, can it be greater than 150? No. Can it be less than 150? Yep. Can it be equal to 150? And the answer is yes. So it can't be more than, but it can be exactly 150 or less. So then we go to our number line, and I'm just going to go like 150, 160, 170, 140, 130, a closed circle on 150. And what answers would make it true is everything less than 150. Okay. The next one, it says Jared earns at least $10 per hour when mowing lawns. So he earns, okay, and then is it greater than 10, less than 10, equal to 10? Well, it says he earns at least 10, so it's going to be greater than or equal to, but it's not going to go less than 10. So X is greater than or equal to 10. So then I would do 10, 11, 12, 9, 8. He earns at least $10, so $10 or more is what he earns. And it goes this direction. Okay, so that is basically your examples.